or we want to solve this log equation, we have 2 times the log of x equals the log of 3x plus 10. Okay, so how are we going to solve an equation of this type? The first thing we notice is that there's only 2 terms, right? On the left, it has a log in it, and also on the right, it has a log in it. And that's actually pretty good, right? The idea is that if you have a log on the left side, so log base b of m, let's say, and you have a log on the right side, log base b of n, right? Because the arguments are different, right? Well, this is called the one-to-one property. We can rightfully conclude that m must equal n, right? The 2 arguments must equal to each other, right? Remember, this is an equal sign. Well, so we see that, okay, remember, if there's no number down here, it's assumed to be log base 10, right? So that's sort of good, right? But what about this 2? How do we deal with this 2? Remember, here we have to use the power rule, okay? So let's bring this 2 up. So log of x squared equals log of 3x plus 10, right? And notice now we can use this one-to-one property, right? Okay. The coefficients are 1. We know, of course, that these bases must be the same. So if the log of x squared is equal to the log of 3x plus 10, what can we rightfully conclude? We can conclude that x squared must equal 3x plus 10. Okay, so we should be able to solve this guy, right? Let's just bring everything over. So x squared minus 3x minus 10 is equal to 0. And this is a quadratic equation. Okay, we should be able to factor this guy. This is x minus 5 times x minus 2 is equal to 0. X plus 2 is equal to 0, sorry. And we should be able to solve, right? X minus 5 equals 0 or x plus 2 equals 0. That gives us our 2 solutions, right? X is equal to 5 or x is equal to negative 2. So are we done with the problem here? And we are not, right? Anytime you have a log equation, you got to make sure you check your answers. So what do we mean by that? Right? What we mean is the argument for log cannot be negative or 0. Okay, so what you want to do is you want to check these in the original equation and make sure that we do not end up with a negative argument. Okay. Well, what happens if you plug in the 5 here? Okay, so we get 2 log of 5 equals the log of, plugging the 5 into, we get 25, right? So of course you can continue this, work through the problem to make sure that these are equal, but okay, we haven't made any mistakes, so we can say, okay, because we end up with both positives, right? And I haven't made any mistakes, then this should work out, right? So 5 works out. But what about the negative 2? Right, notice what happens when you plug the negative 2 in here. We get 2 times the log of negative 2 equals the log, and we get negative 6 plus 10, which is 4. Okay. Well, wait a minute. What is the log of negative 2? Okay, and it doesn't work out, right? Because the argument must be non-negative. Okay. So what does that tell us? It tells us that negative 2 is extraneous. Okay. Remember, it doesn't mean we did something wrong. It just means we worked it out. Okay. But when we plug it back in, okay, it doesn't work as an answer. It's called an extraneous solution. Okay. So we only have one solution here, right? X equals 5.